Okay. So here I try to use the second example for demonstrating how the SiSTeC can be used to visualize structure like this. Okay. Yeah. So here you have the English sentence, you have the Malay sentence. Okay, yeah. So for the English sentence, I use the SiSTeC dependency parser. And this is the structure. So here you have the root, which is occur. Okay, and then followed by the noun. And of course, here you also have the feature, which is the subject, number, singular, and so here, using an existing English parser, we will be able to pass the English sentence into a dependency structure together with their feature capture, annotating to the node. Yeah. And here, the part of speech I basically highlight is next to the word. So this is verb, this is noun. And I noticed that for this Indonesian data set, they are using the similar text set as the English one. Here, this is for the English. Now I show you for the Malay. This is the corresponding Malay one. But this Malay dependency structure is basically generated based on the English one. Okay, and it's basically via the word alignment linkage. So you will see the structure is almost identical to the English one. And the idea here is if we manage to create a Malay dependency tree like this, then it will be probably easier for the annotator to visualize what kind of dependency relationship between the words occur in the Malay sentence. And
so they don't have to start from zero.
Yes, exactly. Also, they don't need to start from zero to build a tree. That is basically making use of whatever visualizer available to assist them to speed up the work. Okay, so here is also a kind of visualizing the structure. But here, apart from visualizing it, we also can perform editing. So here, once the annotator finds that a certain part of the structure is not right, they can actually make changes to it. So here is basically using the standard copy, cut, and paste. So for example, here, the noun is quite okay. Adverb is also okay. Okay. Coming to the preposition, there are different possibilities. It depends on you are doing the dependency or using the deep dependency concept. And the deep dependency concept that were used, they were prefer to have the preposition as a case inside a tree rooted by the noun. So for example, I think here in the annotation given here, they are using this method. So D is a case of the root 7, which is lalang. So lalang is the root, is a parent of this preposition D. So if you like to change into that, then we can always instruct this to become the parent. Okay, so dalang will become the parent, and then okay, it depends on the order. So this is 6, 7, And so D is in front of atau. Okay, D is in front of atau. So you can cut it, copy, cut, and paste, and then here you create a sun. Sun will be in front. Okay, so you can just paste it. So it's the common copy, cut, and paste kind of 3 operation. You can do it here. Okay, so this is how you change this. And of course, inside here, you can now edit the feature inside. So here, it's not a preposition. Inside your current approved, this will be the case. Okay, so you can change it. Okay. So this is one of the aspects, but for my personal usage, normally I prefer the other way around. Preposition become the parent. There is an advantage of that. If you have the preposition as a parent, then you can actually do a conversion of this dependency tree to become a constituency tree.
I see.
They are convertible. But if you go into the deeper level of dependency, then sometimes it could be difficult to decide which one should be the parent. Whereas if you are using the current dependency tree with the preposition and parent, then we will be able to know that it is a parent and work on it directly. So that is one of the advantages of using the surface level dependency versus the deeper level of dependency. Of course, if you are planning to use this parser to do the data abstraction, then people will prefer the deeper level because they will connect directly the main argument now. So you don't need to worry about the preposition and whatever. So it all depends on where is the application. Okay, anyway, so that is just a sidetrack.
Right.
But I think it's important to decide all this. Of course, you all probably have decided already in the guideline to the user.
Correct. Yeah.
Okay, so here the same dengan will have to switch with this baka. So here, this will become the parent, and I will have to cut this, and then create a sun, and I will paste it. So it will become in this format, and similarly, I will have to. Okay, so this one is conjunct because of there is atau here. Okay? So this become a conjunct of the previous head. Okay, that's fine. But we also have another conjunct here, dan.
Yeah.
Okay. Okay, so we probably want to check which is the conjunct of which. Okay, so here. Okay, so this is the conjunct. Okay, this is the conjunct, so it's right. So we will know that this conjunct with this. And then the other, it look quite okay. Okay, so here it might be minimize changes if the dependency tree between the English and Malay is quite identical. Or it can be major changes if the translation of the Malay sentence is with a very different structure. So it all depends on the parallel sentence given to see how we can maximize the usage of the Malay dependency tree created. Okay. But apart from this, if, for example, in this case, we already have dependency structure created, then maybe one would like to visualize to see how is the tree like, and that will probably easier for the reviewer to double check again to see what is the work done by the annotator. Okay, to visualize to check in this way is probably challenging. So that can also be done with visualizing mechanism like this. Okay. So this is the structure, the dependency tree created based on this one, manually, of course. Okay, so I look at this and then I try to create. I think it should be right. So here you have the root form. You also have the features under it. So for example, here, serangan, the root form is serang. Okay, if you look at it, serang, and then it's the end subject, number singular. Okay. So we can also try to capture it and then to allow the reviewer or annotator to double check on the dependency tree, visualize in this manner. And of course, we can also try to compare in between the two. Okay, so here, this one is basically the one generated just now by the English by referring to the English dependency tree. And this one is the one generated from the data set here. Okay, now, if it's not for demo purpose, we can actually visualize the tree with a smaller form. Then most likely the tree will be in one screen on both sides. But never mind, we can always adjust. Okay, so here, this now sub-tree is identical, no problem. Biasa is also same. Okay, D atau is different because we just make the changes. Okay, to have the D go down and dalang go up as a parent. So this is the different part. Okay. And then the dengan go down. Yes, so this is the different part. Okay, there is one thing which is different here, which is the conjunction. Okay, dan conjunction is under the membaka. Okay, whereas over here in the annotated tree, it is under memega. Okay, so here we will have to check which is the conjunct. Okay, memega is the conjunct. Okay, so here dan shouldn't be under a conjunct. It should be above, so that we know that this sub-tree is conjunct under this coordinator, this n, dan. So for example, like here, we know that there is a dan here, which is CC. Then in order to know which is the conjunct, we will look for the sub-tree rooted by a conjunct. Okay, so here the English one is probably easier to process. So in this way, if the annotator would like to change, they can do the same, like what they have been done earlier. You cut this, but this round you have to create a brother, not a son, so that it next to this one. Okay. Okay, now there is a conjunct here. Now we'll be able to identify among this 1, 2, 3, 4, which is the conjunct of this, or this is a conjunct. So this will be the tree in conjunction with this bigger tree here. So for example, the reviewer will probably do checking like this, and it might be easier for the reviewer to see anything which is need to be improved further. So
Yep.
they can compare the tree generated from the English and also the tree given by the annotator in this manner to double check. So that is for the reviewing. Or if they are already annotated, then it can be compared in this way. If any reviewing of the existing data would like to be done in this way.
Yep.
Okay. So that is roughly, I think, what can be done with this editor. Of course, if we want to use it, then we will have to establish the workflow. How to take the input and then start generating all the things so that the user can open it and then do the task accordingly.
Right.
And then after that, how we collect the result and generate into the format like this, so that this can be again used by the Allen NLP trainer or Humming Face trainer to perform the training to generate the model.
Yeah.
So this will be the workflow we need to look into after this. As I mentioned just now, if we were to use a dependency tree as generated by the English dependency tree, oh no, this is already a modified one, never mind. Okay, then we can also try to explore how to convert a dependency tree into a constituency tree.
Okay.
Okay. In fact, I'm also trying to look into your data set of the constituency tree. Okay, so this is what in your data sets for Indonesia. Okay, they are using the X-bar theory to create the tree. Again, it all depends on what is the use of this constituency parser by the user. Some might prefer to just represent it as commonly represented constituency tree without really explicitly identify and specify the X-bar slot of it. Okay, for example, a tree below here for the English translation, this will be the tree normally produced by the constituency parser, by the existing English parser. Okay, anyway, again, this is can be standardized, depend on the need of this parser. If it's a grammar checker, probably you need X-bar. If it's for the natural language processing to get the sub-tree or phrases, then probably it's a common constituency structure. So here, for my case, I'm showing how to convert a dependency tree into a common constituency structure. So here, normally the idea is the root will be replaced by a sentence S, and then the noun will be dominated by the parent MP. So by inserting additional label in this way, slowly you will be able to convert this tree into a constituency tree. So by creating a phrase structure in this way, we can also prepare a dependency structure tree for reviewing or for checking. So a similar set of sentences now can produce the dependency tree as well as the dependency tree. And
Right.
don't need to create from scratch. So you can again edit based on whatever which is generated.
Right.
And since we have the part of speech tag here, so part of speech tagging data set is automatically can be extracted out. So the part of speech tagging, dependency tree parsing, and the constituency tree parsing data set and the dependency tree data set, all three can be generated for a given set of sentences. However, in case the given set of Malay sentences have no English translation, we can also try to find a solution to it. And it's basically making use of the machine translation. Okay,
Right.
so we use a Google Translate to translate, and most of the time it's quite okay to generate a tree for editing.
Right.
So it's given what the current state of the NLP technology maturity is, a lot of things can be done to assist this effort.
Right.
Yeah, I think that's all. I think what so far I can explore. Of course, on the way we probably will discover other means of automating something or improving the method of annotating or reviewing, and also the workflow.
Yep.